Now finally we do study the volume integrals, and the volume integral is such that we will have an integral on a volume, and it will be a scalar function, and the volume element I can write is dv or d tau. So for this one, we are having the restriction that t is a scalar function while d tau is in infinitesimal volume or a differential volume. In Cartesian coordinates, we are having this d tau equal to the differential x component, then the differential y component, and finally multiplied with the differential z component. Now, if for example this T is the density of a material when multiplied with the volume, then the integral on a volume T d tau will give us the mass of the material. And if for example we are having this T is rho, like the volume charge density, and multiplied with the volume, then we will get the total charge. So it is a scalar function. T is a scalar function. Now in case we are having a vector function, for example we are having the volume integral, and this is function v and d tau, then in this situation we will have to write this thing is this v will be the x component of it in x unit vector plus the y component of it in y unit vector and the z component of it in z unit vector multiplied by d tau here. So I will take here the components like the x unit vector outside of the integral because it's a constant thing here, and vx then on d tau. Similarly, I will have plus y component and then vy d tau, and similarly the z component and vz d tau. So this way I can treat the vector function on a volume integral. So the volume integral is very important in electrodynamics, and in order to understand its importance more, let me solve example 1.8. So this is example 1.8. Now example 1.8 is a bit tricky because here is a coupled equation. Now let me recite this example 1.8. It says calculate the volume integral of t equal to xyz squared over the prism in figure 1.24. So let me first draw the figure and then we will discuss it. This is our coordinate system, and we are having our x, y, and z axes. This is our x axis, this is y axis, and this is z axis. Now the prism is such that we are 1 point on y and 1 point on the z axis, on the y axis and the x axis, and then 3 points on the z-axis. So this is something like this. It is connecting here, and then we are having this one to be here somehow here. Okay, and this one is slightly, I will have to make it tilted in order to make it visible in just like in 3D. So here this is the straight one path, so it is almost here, so it is like this and then touching here, and this one is connected to this one, so it is somehow like this. We are having here point 1 and here it's on 1 and this one on 3 here. Now the function that we are having is t equals x y z squared, and we are supposed to calculate the integral, the volume integral, which is volume, and we will calculate this t d tau, and then this is equal to a volume integral and x y z square and d tau. Now here is something that we will have to take into account. I know that, for example, if I do like this, that this is our origin 0 point, so x is running from 0 to 1 here, while y is running from 0 to 1, z is running from 0 to 3. But if I look here, this, when I change x, then y is changing as well on the prism. So if I say that x is running, if I say that x is running from 0 to 1 and y is also running from 0 to 1, then basically I will be calculating not this line but this line, which will be like this. But I will have to calculate half of it because the prism is here and this is lifted up. So it means these two are coupled here, and then as I take z, so z is running from 0 to 3. There is no problem with the z, but there is a problem with the x. So if there is a solution, means I will have to couple this x and y here. So if I take y from 0 to 1, then I will take x running from 0 to 1 minus y. Or if I say that x is running from 0 to 1, then y will be running from 0 to 1 minus x. So that I will have to take into account, because when x is 0 and y is 0, so we are at this point. When x is equal to 1, then on the x-axis, the y, if it is equal to 0, then we are exactly here. But when this one is means moving like this, then from here to here y is running from 0 to 1 while x is running to 0. So that's the reason that we will have to take this, means when y becomes 1, then x should come out to be 0. So that we will have to keep in mind that we will have to couple this one, otherwise we will be calculating not the prism line but the line which is this parallelogram or the rectangle. So keeping in view the limits, first I will calculate z because it is independent, and then I will come to the coupled x and y. So I will calculate y in terms of x and then x in terms of y. So it will be like this, that the integral, this integral is equal to the integral on z, so this is from 0 to 3 and z square, and it is the dz will be afterward I will write sub, and then I will write a coupled integral, and the coupled integral is such that it is the y integral and y is running from 0 to 1 and y here, and then will be the integral of x. So the integral x is running from 0 to 1 minus y, and then x and dx here, and then I will complete this one, and then will come y dy here, and after this will be dz. So this is the way to do this thing. If I will write y here, means here in this limit, so x will be here, then y dy will be here, and from 0 to 1 minus 6, and the result will not be affected, because I know that the x and y are having the same power, means it is changing diagonally here, and the coupling will be unaffected if I take it on y as well. So now this one, first I will calculate the x portion, and the x portion is that it will be x square over 2. So I will have x square over 2, and the limits are from 0 to 1 minus y. And then I will have dy here, the dx portion is gone, so dy here, and here y, and from 0 to 1 here, and then we will have z square, and here dz, and the limits are from 0 to 3 here. Now I can put the value, but the integration is on this one as well, means it is coupled with this. So what it will be, it will be, means this 2 I can move outside, so we will have half, and then 0 to 3 and z square, 0 to 3 z square, and I can make dz with this one, because the dz, it is independent of it, so make it with this one, and then I will write integral 0 to 1 and 1 minus y whole square, 1 minus y whole square y dy. And now I can solve this one further. So it will be, this is equal to, I will take this half here, and then z cube over 3. So I can simplify this one here as well, that this will be z cube over 3, and from 0 to 3, so it is z cubed, it will become 3 3s are 9, and 9 3s are 27 over 3, so it will come out to be 9. So I will write for z here 9, and then I will write integral from 0 to 1, and it will be 1 minus y square, so it is 1 plus y square, and minus 2y into y dy here. So this is equal to 9 over 2, and now I will write this integral, and integral is from 0 to 1, then it will be y, because this y is multiplied here, y dy, and then it will become plus 0 to 1 and y cube dy, and minus 2y square minus 2, from 0 to 1 y square dy here, and this is equal to 9 over 2, and then the first term, it will come out to be y square over 2, and y is 1, so we are having 1 over 2 here, plus this will become y 4 over 4, so it will come out to be 1 over 4, and then minus 2y cube over 3, so it is minus 2 over minus 2y cube over 3, so it will come out to be minus 1 over 3. And now I can further simplify this one, that this will come out to be 3 fours are 12, so this is equal to 9 over 2. Now this one I can simplify by just, if I take 12 as the LCM, then this will become 6 plus 3, 9, and then 2 twos are 4, so 4 twos are 8, means 9 minus 8 will come out to be 1, so 1 over 12 is here, and this thing is equal to, I can further simplify with 3 threes and 3 fours, so it comes out to be 3 over 8. So the volume integral of this one of t x y z square comes out to be 3 over 8. So the technical thing in this example, or the difficulty in this example, was that here we are having x and y changing together. So we will have to take the limit carefully, and then when we will come to the integral, then it will be a coupled integral. We will do this one and convert this one in terms of y, and then we will take the y integral. While z is independent, it is just we have raised this thing up and it has made a prism. Don't do this mistake to run it from 0 to 1 and this one 0 to 1 independently, because then we will be making a rectangle and we will be raising the rectangle upward. And with this we are done with the line, surface and volume integrals, and from the next lecture we will be starting with the very important theorems, means the fundamental theorem of calculus, then the fundamental theorem for gradients, divergence and curl.